Indicators of succession in Point Pleasant Park following Hurricane Juan, moving towards a climax community. To understand our presentation, we must first define a few terms. Succession is how a biological community changes over time. There are two types of succession. Primary succession takes place where no soil has existed initially, and secondary succession takes place in previously colonized areas after a disturbance. In this case, the disturbance is Hurricane Juan. Hurricane Juan took place in September of 2003 and caused severe damage to Point Pleasant Park. To understand the results, it will be helpful to know DBH means diameter at breast height, which is how we measured our trees. H is Shannon diversity, which captures both species richness and species evenness. J, which is Pilus evenness index, measures how evenly individuals are distributed. And finally, S is the species richness, which is the total number of species in a community. Point Pleasant Park is an important part of the Mi'kmaq creation story. Halifax downtown area up to Point Pleasant Park was known as Amukati, which means spirit place in English. The Mi'kmaq believed that this is the place of the Great Spirit Fire gave birth to the 7 original families of the Mi'kmaq people. This is told in the last level of creation. As documented in Burley et al. 2008, Point Pleasant Park showed strong natural recovery after Hurricane Juan. Our study adds more data to support this study and others.
Our hypotheses for the 3 questions we will be answering are the following. The total density will increase. The forest is gradually recovering from the hurricane, moving towards a more stable state. At the same time, DBH of trees will decrease, suggesting a shift towards younger trees. This trend is a result of disturbance recovery. The density of red maple and red spruce trees will continue to increase over time. And the community metrics will show increasing species richness, higher diversity, and a progression towards late successional species over time. As the forest moves towards its climax Acadian community, the metrics will stabilize, showing a mature and balanced ecosystem.
Data was collected from 6 20-meter by 20-meter sites. The locations of these sites were chosen based on areas with the highest hurricane impact on trees and vegetation. The location of these 6 sites within Point Pleasant Park can be pictured over here. 6 open reel measuring tapes were used to section off each site as well as to divide them into 4 quadrants. Diameter tape was used to measure the diameter of the trees at diameter at breast height, DBH, which is 4.5 meters off the ground. Only trees with a diameter greater than 2.5 centimeters were considered, and measurements were taken to 2 decimal places. Pictures of trees were taken on iNaturalist and using the suggestion feature were identified to the species. For data analysis, Excel and RStudio were used. Excel was used for summary statistics, community metrics, as well as calculations of Shannon Diversity Index, H', and Pilus Evenness Index, J. RStudio was used for linear regression analysis. This type of analysis was chosen because the independent variable time and dependent variables, density and size, displayed a linear relationship. We also wanted to determine the relationship between time and our dependent variables, total density, DBH, S, H', J, the density of red spruce, and the density of red maple, as well as the amount of variation in our dependent variables that was due to time.
The first question that we examined was how was the overall forest community changed over time, why, and what can you predict will happen to the overall community as the forest moves towards its climax community, and why. The graph displayed shows a positive correlation between the year and the total density with an R-squared value of 0.4485. This indicates a strong relationship between the two variables. The increase in density is a result of natural succession. Older species are replaced with immature early to mid-successional species, such as red spruce. This reflects the extent of hurricane damage. As the population reaches its climax community, we could expect density to plateau as competition for resources gets stronger and more trees die off. Furthermore, this graph shows a negative trend in dBH. The R-squared value is 0.1491, which indicates that there is not a strong correlation between the year and dBH. The negative slope suggests that older and larger trees are declining while the smaller, younger trees increase and become more dominant. As the forest moves towards its climax community, the dBH will stabilize as species mature. Competition for resources will slow the growth rate and lead to fewer larger trees.
Linear regression analysis was used to examine the effect of time in years on the density, number of trees per 400 meters squared, of red maple and red spruce trees after a major hurricane. There was a positive relationship between red maple density and time, and therefore the red maple density increases with time, as can be pictured here. There was also a positive relationship between red spruce density and time, and therefore the red spruce density also increases with time, as can be pictured here. The density of the dominant species of 2004, the red spruce, as well as the density of the dominant species of 2024, the red maple, have both increased with time, as can be pictured in the graphs over here. This is because the Point Pleasant Park forest follows the typical natural succession pattern, where, over time, small ground vegetation gets replaced with early successional tree species, which increase in density. As the forest moves towards its climax community, the dominant red spruce and red maple trees will experience thinning as competition underground for nutrients and above ground for sunlight increases. This will result in a decrease in the density of both species.
The first biodiversity metric, species richness graph, displays a positive relationship between the time in years and the species richness, which is the number of species per 400 meters square. We see a clear upwards trend from 2004 to 2025. Right after Hurricane Juan, the number of species was relatively low, but as the forest recovered, more species began to establish. The overall rise in richness shows that the community is becoming more diverse and structurally complex over time. The second biodiversity metric, the Shannon Diversity Index, displays a positive relationship between the time in years and the Shannon Diversity Index. Similarly to the previous graph, we see a clear upwards trend from 2004 to 2025. The Shannon Diversity Index increases with time, which shows that more species are present, but also that their abundances are becoming more evenly distributed. The observed trend after Hurricane Juan is an initial increase. Species richness increased as early successional species colonized newly opened canopy gaps. There was a continued gradual shift. The forest moved from distributed open conditions towards more competitive conditions. The disturbance reset the community, creating conditions typical of secondary succession. In addition, light availability increased, favoring fast-growing, shade-intolerant pioneer species. As the forest continues to recover, we can predict that the community metric will keep moving towards values typical of a mature Acadian forest. Early successional species will continue to decline, and shade-tolerant species will become more dominant as the canopy closes and competition increases. Because the environment becomes more stable and shaded over time, the community is expected to shift towards fewer, longer-lived species with larger biomass. Eventually, the metric should level off as the forest reaches a climax community. Based on the trends we observed in the community metric, we can conclude that Point Pleasant Park is currently in a mid-successional stage. we're seeing a mix of early successional species like red maple alongside increasing abundances of late successional species such as red spruce. This tells us that the forest is actively transitioning, but hasn't yet reached the structure or stability of a mature Acadian forest. Because Point Pleasant is an urban park, there are human pressures that slow or redirect natural recovery. For example, trail use, which compacts the soil and makes it harder for seedlings to establish, which can delay the transition into late successional stage. When we think about long-term forest recovery, combining Western scientific knowledge with Mi'kmaq traditional knowledge can give us a more complete understanding. Mi'kmaq teachings emphasize stewardship, long-term relationships, and caring for key species. Approaches like protecting culturally important native species and selectively removing harmful invasive species could help us guide Point Pleasant Park more effectively towards a mature Acadian forest.
We would like to acknowledge the contributions of all Biology 2060 students, past and present, who have contributed to data collection, as well as Dr. Joanna Zigris and Dr. Allison Schmidt, who designed the lab. We would also like to acknowledge our demonstrators and markers who helped with data collection and data analysis, as well as our peers who reviewed and gave feedback on this presentation.